Hi guys, this will be part 4 of our Kicad tutorial. Maybe I will split this part 4 in several pieces because I have very long videos as I'm going slow. So in this part we will, I'm not going to be ordering this PCB from manufacturer. I will do it myself at home. And I just received these Farnell parts, and I think our board will be okay. And I have in my hand a piece of PCB exactly 100 millimeters long and a bit wider, so I will cut it off, and I will show you process with that in a later video. But before, I already showed you, I already recorded that in a video, and before I proceed with this, we need to make sure that our PCB will print okay on in Kicad. So usually before I start printing, I just check the dimensions of boards once again. So for that I will move my grid into millimeters, and I will just check once again. I'm pressing space to reset coordinates, and it's 100 by 40, so okay, 40 millimeters. And yeah, I can see that this component is not in line with this one. If you edit your component, you can see it's on 95 on y-axis, and if you edit that one, it's 96 on y-axis. So I will just delete these parts with backspace. I'll delete just this part of tracks with backspace, like this, and also this and this, just in order to make them symmetrical. You don't need to do this for your circuit, but well, looks much nicer. I will move it with letter M. So let's space it a bit apart, like this, 1 millimeter to here. So we have 1 to 3 millimeters, 6 millimeters between these two. I believe this will be enough. Maybe we can push it in and make it 8 millimeters. Well, 6 is good enough. Okay, 6 is more than enough. And 1, 2, 3, 1, 2, 3. This is okay. So I'll press X to start drawing my components again, and let me I was thinking about rearranging these. I can see now that I have millimeter and a half between 2 millimeters between this hole and the edge of a board, so I might just move this connector a bit down. So I'll delete complete track, and I'll delete also this one and this one. So let me move this. I press escape, and I will move this over here, and I will delete this track also completely. Okay, well, while I'm at it, I will rearrange everything. Give me just a second. Yeah, I can see that there's a lot of space over here, so I will move this one here to the edge, this one also, and I will move this a bit here. Yeah, now it's much better, and this is okay. So I'll press X to go again to, oops, you can see I'm on the wrong layer right now. Somehow I pressed the wrong key, and Kicad just presumed I want to draw on another layer. So when this happens, you press escape, and then you press letter V, and the layer changes, as you can see on the top right corner. So we are now on the top layer, and we can connect this. We can connect this. I can connect this one and this one, and then I have a ground path here, to here, and then from here to here. Oops. From here to here. Yeah. And then we have connections from here to over here. That's good enough. And then we will have to do this over here between these two. Let me just delete this and this. I will spread these two resistors a bit more apart. I will move it. Now they are 1, 2, 3, 4, 5 millimeters away from each other. Okay, that's good enough. Press X to start drawing again. Here to here, and then I will use this gap between them to put a line between them, and I'll okay, and then we will have to push this in. For that I will need a grid of 0.5 millimeters. I will zoom in and just barely get out. Nope, let's use grid also 0.25. I will yeah, this is fine. So at backspace you delete last you delete last point on your track. So let's say you put your point like here, you cannot move it anymore, but then you press backspace and it will delete that last point. So I want my last point just to be like 40. In order to have 45 degrees connections, I will put this this elbow on a track right here, and then I will just connect it with double click. Okay, and let's delete this and connect a new, complete new line like this, and then I will do the same over here. Yeah, okay. Okay, I will save this, and the next thing you need to do is prepare your board for printing. As I will be using special paper for toner transfer, I don't want to waste a lot of this paper, so I will change, with this icon here, I will change orientation of my paper to portrait. This will take some time. Okay, I need to just press OK. Then I will select everything, and I will include items on invisible layers. I'm not sure what did I put on invisible layers, and I will move it as close as possible to the edge of a paper. If you zoom in, you can see. Maybe you can. This is good enough. The reason I'm doing this is because I will be using toner transfer paper, so I don't have much of this paper, and I'm not using it often, so I do not want this image, this PCB, to be printed on the center of a PCB, on the center of a toner transfer paper. And also, if you want, you can put on top copper. We can put some. Copper letters like this, and let's put them like 5 millimeters long, and height and thickness is 0.5. Okay, so I will put these letters. So let's say 5, 0.5, and I will try to put it over here. So this will be etched. This will be etched when this part will be etched during the process, so this letter will be visible in the copper layer. Okay, this is more or less everything. So now I need to go to print dialog, and I will print out copper layer in black and white, and I will mirror it for top layers. I will mirror it, and I will not print the frame references. I'll go over here to preview. Yeah, this is it. Okay, this is the part of a PCB I will use to develop this circuit board. I've searched through all my scrap parts over here, and this one is exactly 100 millimeters long, and I will just have to cut off a small part of this, and I will use a toner transfer method. I won't be getting into details, I won't take any pictures of it because you have plenty of tutorials on how to do that. I'll just show you intermediate steps. So first thing I'll do here is just cut off the excess of this board over here, and then I will clean it. I will give it a thorough clean, and also with some memory paper I will scrub the surface, and after that I will just print out the toner and transfer it with a household iron. Hi guys, just a small update. So in previous video I showed you my board, so I cut it. I just scored it with a knife, and then it's extremely easy to break. Then I printed out this on a piece of ordinary paper. I printed out our PCB mirrored, our copper layer, and we can see here that if you check this is not 100 millimeters long. Yeah, here. So it's 95.88 and 38.4. So we need to scale. So the printer reduces the size of my printout. So I needed to calculate the coefficients I need to use in order to have 100 millimeters exact. This is you have to do this on a lot of printers. So each printer that you use, you need to first print out the PCB and then calculate the coefficients, just the scaling adjustment for your printer, in order when you print out the PCB and you're etching your copper, so that everything will be in scale. This is very important, especially for the SMD components. Maybe not these ones, but for smaller SMD components, this is extremely important. You can see my coefficients here. You can see these two numbers. It's about 4% off, and I will show you like this here in a Kicad. So I used these two coefficients. I just put them in here in X and Y scale adjust. I printed it out, and it's over here. I printed it out, and this is new printout, and if you measure it, this is exactly 100 millimeters by, let's see, can I fit this, by 40 millimeters. So this one's fine. I will be using this one. I will put the paper right now, and then print out toner transfer paper, and I will print out a new layer, this copper layer, on a toner transfer paper. Okay, so I printed out this pattern, the copper, so on a toner transfer paper, and I use a toner transfer paper purchased from this company, Dip Micro, in Canada. So the next thing I'll do, I will cut off this this pattern over here, and then I will prepare surface on my board. I will clean it thoroughly, and then I will press it with iron. After that, I will come back to show you a result. Okay, I don't know, can you see this? The board is now clean. I cleaned it with alcohol and solvent, and my toner transfer paper is ready. So the next phase is just pressing this. So I will try to press this, and I'll come back in a few minutes and you will see the results. Okay guys, this is result of my toner transfer, and I'm satisfied with it. And you can get even better results if you're a bit more careful. You can see here I've lost some toner, but this is okay, and you can repair this with a Sharpie before etching. So I will just drop this in a ferric chloride for like half an hour until it's etched, and well, this part of making a board will be completed. These are the tools I will use after etching. The board is etching in the ferric chloride solution. So the next thing I'll do, this is overhead transparency, and I will print out this pattern on it. Before that, I will paste this paint, UV paint, on board, and I will spread it around, and I will expose it through this pattern. So this is actually this part will be solder resist, and after that I have this film over here, and I will stick that to a piece of paper with double tape, and I will print out my silk screen on this, and I will also apply it with an iron. So hopefully after when I finish with all this, we will have completed PCB with solder resist and silk screen. Okay, this is final result after etching. It took about an hour because I didn't put so strong solution. So this is complete board. You can see over here just few devs because I tried to write something with a Sharpie here just to test my Sharpie, is it working, but apparently it wasn't strong enough. So okay, so the next thing to do here is we need to put UV paint over this and spread it around. Cover with I will cover this with cellophane paper, and I will UV expose it for about half an hour. After that I will record the result. Okay, and this is the board after spreading UV paint. It's not perfect. You can spread UV paint around with a credit card. Well, as I said, it's not perfect, but I think it's good enough. So I'll expose this and I will check the result after that. Hello guys, so down you can see final PCB with solder resist on it. I'm not fully satisfied with it because, well, I should use a thicker solder resist, and so some of the copper traces are still visible, still uncovered, but I think this will be good enough for the purpose. I'm not going to put silkscreen on it because I spent all my adhesive spray. I thought I had some, but I've just tried and there's nothing inside, so I will be closing this box as it is. I will be soldering this down, and I will record my soldering, and I will also post to YouTube. So this is the final board after etching and applying a solder resist. So next step is to drill these holes here and drill the holes for mounting a PCB. And this is a case for mounting PCB, so it'll fit. So now we need to drill these holes and 4 holes on the corners. And after that I will solder the components down and put the cables in, and I'll record soldering. Okay, I got the board drilled, and I had to drill these 2 holes. I had to drill wider because well, it wouldn't fit in a box. You can see later. Also, I drilled these holes for the cables, and I will now start soldering. I will be using small tweezers. I will be using a multi-core. Let's try to get the camera to focus here. I will be using 0.56 millimeters. Okay, and first thing I'll do, I'll put some solder on one of the pads, and after that I will place a component, and then I will solder the other pad. So I hope that camera will manage to focus while I work here. So I will use some flux in a pen, just a small amount of flux in a pen on one side of each component, and then I'll clean my soldering gun and I'll put some solder on here, then a lot over here, and then on the places of these 2 resistors. So the next thing, I'll take a diode, and I have my screen opened up here. I don't know, did you notice, I didn't put my silkscreen here because I didn't have adhesive spray for it, and I had to wait it for ordering. I spent it all, so I'll be doing it without it. So I will just preheat this small dab of solder over here, and then I will place my component. Okay, let me just push it a bit over. Okay, so this component here over here is, let me just try to show you better. This component over here is now sticking to one side, one pad, and I will do the same with these 2 resistors. The top one is 300 ohms, the bottom one is 1 mega ohm. So I'll just take a resistor, let me just put it in the middle. I don't know, can you see this? And I will preheat this solder over here, place a resistor, and I will make sure that I will have enough on the other side. Yeah, that's it. So I was making sure just that I have enough on the other side, so I can place some tin over here. I will take this 1 mega ohm resistor, preheat the pad and place it over here. Oops. Yeah, this is okay. Let me just push this a bit over. Yeah, I think this is also okay. And the last one I'll be doing, and then can the camera focus over here. The last one I'll be doing is the biggest one. I will preheat this for a longer time and then I will place it down, and then I will heat it for a bit longer than the other components. Okay, I'm satisfied with it. So I will take some more thin soldering wire, and then first I will try to do this. Let me put some more light over here. I'll do this with the capacitor. I will try to put some more heat over here. Okay, I will do the same. I will do the same thing with the diode. Let me clean my iron. Okay. Okay, that's it. And then I'll do that with these two resistors over here. One is okay, and the other one, I just leave my iron on some time so it has time to heat up the component and the pad. Okay, well, I'm more or less satisfied with the result. You never know with these big capacitors. So most probably I'll have to glue this down also, in order, in some of the shades the box, there's a possibility that capacitor will fall off. So I will glue it down for sure. And also I'll just try to press it once more and reheat it again. Okay, this side's okay, and let me do the same thing on another side. I put a bit too much solder over here. I was hoping it'll soak in. Yeah, okay, and that's it. So, well, I'm satisfied with the result. The next thing, I will pass the cables through here and over here and solder the cables. I already drilled the holes. I don't know, can you see? I already drilled the holes. This one is 3 millimeters wide, and this one is 1.5 millimeter wide. So that's enough for the cable to pass over here and then go up here, so I can solder it down correctly. So the next thing I'm doing is preparing the switch. I will be soldering these 3 wires. I already prepared them. They're about 10 centimeters, about 3 to 4 inches long. And I will solder each terminal of this switch. And after that I'll put some heat shrink tubing. So when you're soldering these big components as switches, you need to hold your heat a bit longer than usual. So you need to heat up the pad and let the tint flow onto a terminal like this. So next I'll do a center one. Okay, and the last one. Okay, so this is good enough, and I have these three heat shrinks tubing, so I also cut off the excess of wires from the middle terminal because I think they're too wide for this. They're sticking out, and I will pull out everything that I can with the tweezers and cut off the excess here, here, and also here. So next thing I'll be putting heat shrink around it. Ooh, this is something sticking out of this part. I'll cut it off, and also here. Yeah, let's try again. Okay, this one's okay. And first and last terminal also. Yep. Okay. And I'll start up hot air gun. And I'll wait just for a short while until this hot air gun is warm enough to shrink the tubing. Okay, this is good enough. So I have my switch ready now, and I will be soldering last two parts of wires here and here, and also plugging in the switch, and after that I will be drilling the holes in my case and putting everything together. Okay, so this part is, I have these three wires from the switch pre-tinned, so I put them through the holes and I pre-tin them so there won't be any wires, small wires, individual wires sticking out. So I have everything ready. I will solder now these three and pull these wires after that, so they will have a support. And then I will do the same thing with these input and output wires. I don't know the camera focus, but I'm satisfied with the result. I let the solder to cool for a moment, and then I will cut off the excess. Okay, this is good. I will be gluing this capacitor after I'm completing with everything, and then I will put a conformal coating over it. So I will pull these wires a bit out. Now can you see it? Yeah. Okay. So this now can fit in my box, and these holes in the PCB, they provide some string relief if somebody pulls on the wires. I have the same setup here. I have the helping hands holding my piece, and I will try to fit in my soldering iron, and I will be soldering these 4 wires, and then I need to drill through the casing before I put everything together. So I will start with this one. I already pricked in the wires. I put them through my holes here in a PCB. And technique for soldering this is you put a little bit of thin on your tip of your soldering iron, and that will transfer heat to the rest of the part like this, and then you flow in the rest. Same on the bottom part. Hold it a bit. You wait it until it flows all around, and then you can remove your iron. I'll do the same over here. So one part of the iron is touching the wire, another one is touching the pad. So this is chisel tip iron. Okay. And the last one, I didn't put fume extractor on because it makes a lot of sound. It's hard to hear. And we're done. Okay, let me remove this. And so the final board looks like this. I will pull these wires through, and this one also, and on the other side one and another, and this is okay. So the next thing I need to do is clean the solder flux out of here. I will do that with the isopropyl alcohol, and then the board is ready to be mounted in the casing. Also, before I do that, I will cut off the excess of wires. This one and this one here and this one here, and then I will glue this capacitor over here and coat everything with conformal coating, and I will be completed.